All right, so today what we're going to talk about is, first of all, we'll finish up section 1.2. So in this, my goal is for you all to be able to find the intercepts of equations and also to use equations of circles to solve problems. So two key concepts, one is intercepts, the other one is circles. Okie doke. So to start off with, I'm going to get straight into an example. And what I want you all to do is find the x and the y intercepts of the following equations. We'll do two. So the first one's going to be y equals the square root of x plus 4. Okay, so the goal is to find the x and y intercepts of y equals the square root of x plus 4. Now up here, I'm going to add algebraically to this, and I'll show you what I mean by that in a moment. So let's go ahead and graph this first of all, just to give us a visual. So I'm going to graph y equals the square root of x plus 4. And you'll notice in Desmos, it does a really good job if you click on the actual line. So I'm using my finger to click on that red curve. If I want the x-intercept, I'm going to click over here. So I just clicked on that little gray dot that was there. It tells me what the x-intercept is. And then if I want the y-intercept, I'm going to click on the other gray dot. And so now I actually know what the x and the y-intercepts are. Pretty cool. So that means that when we're solving this problem, we basically know what our answers are graphically. So from the graph, we know that x equals -4 is the x-intercept, and y equals 2 is the y-intercept. However, I said I wanted to do this algebraically. So here's what we're going to do. Notice that on this graph, if you are on the x-axis, the y value is 0. It's -4, 0. And if you're on the y-axis, the x value is 0, 0, 2. So what we're going to do is set x equal to 0, and this is for finding the y-intercept. So I'm going to say y equals the square root of 0 plus 4. So that means that y equals the square root of 4, which you might have already gotten is 2. And that checks out with what we found from the graph. So for the y-intercept, I set x equal to 0. Now for the y-intercept, I just mixed it up. For the y-intercept, I set x equal to 0. For the x-intercept, I'm going to set y equal to 0. So now we're solving the equation 0 equals the square root of x plus 4. Now you might remember, in order to get rid of a square root, you square both sides. So I've squared a square root. Those are inverse operations of each other. So that leaves me with 0 on the left-hand side and x plus 4 on the right-hand side. Solving for x, I do in fact get -4, which, as we saw, checks out. So if I was doing this problem, I would now say, basically I would circle my answers. This is the y. Sometimes I'll put a little int on there, x int. So what I might say if I was doing this problem is I might say y-intercept is 2 and x-intercept is -4. So this is good habit to be in. And so now we have our final answer. Okay, let's try another one. So the second one we're going to do is x squared minus 8x minus 20. Once again, you could graph this, but we want to do this algebraically. So the first thing I'm going to do is set x equals to 0. And as you probably remember from just above, this means we're solving for the y-intercept. So I'm going to plug in 0 squared minus 8 times 0 and then minus 20. If you plug this into the right-hand side into a calculator, or you might be able to just do it in your head, you should end up with -20. And then on the other side here, to save some room on my paper, I'm we're now going to set y equals 0. That's going to give me the x-intercepts. So we have 0 equals x squared minus 8x minus 20. Oh, good, we get to factor something. Now this is a quadratic expression on the right-hand side because it has an x squared, so this is quadratic. And if you recall from maybe Algebra 1 or Algebra 2, to solve this, there's three options. You can use the quadratic formula, you can complete the square, or you can try to factor. Now, factoring should always be your number one choice. And essentially what factoring does for us is it says we're going to have two factors here such that when I multiply all these out, I should end up with my original there. So let's go ahead and start to factor. So I need two numbers that multiply to negative 20 and then add up to negative 8. Now that's a terrible looking 20, so let me erase that real quick. Negative 20. So hopefully you might try some here. 4 times 5 gives me 20, but 4, that does not add up to 8. 1 times 20 gives me 20, but that doesn't add up to 8. I think the answer is going to be 10 and 2. And in this case, I'm going to have to subtract 10 and then add 2. So notice if I were to multiply that expression on the right, I should end up with my original of x squared minus 8x minus 20. So the reason we do this is because the next step is to set each of these factors equal to 0. This is called the zero product property. So I'm going to write this as x minus 10 equals 0 and then x plus 2 equals 0. And now you might just be able to see the answer, or you could use what you know of solving equations to end up with x equals 10 and x equals negative 2. And that should agree with the graph if you graphed it. So to summarize our answer, we have the x-intercepts, which are 10 and negative 2. And then we also have the y-intercept, which is negative 20. We are done with that problem. Great. So the next concept I want to cover is graphs of circles. And the first piece of this that I want to talk about is just kind of the general equation. The general equation is x minus h squared plus y minus k squared equals r squared. Now let's talk about what these mean. X and y are the variables. Those are your typical x and y in any equation. H and k come together to form an ordered pair, and this is called the center of the circle. And then R stands for radius. So for example, let's say I wanted to graph the equation x minus 2 squared plus, and then we'll do y plus 3 squared. We'll say all of this equals, let's do 16 is fine. Okay. All right. So the center is going to be 2 for h. Notice that it's y plus 3, not y minus 3. That means that the y value of the center is actually going to be negative 3. It switches. And then the radius is not 16, it's the square root of 16. So in this case, that comes out to 4. So if we graph this equation in Desmos, we're going to have x minus 2 squared plus y plus 3 squared equals 16. And this is pretty cool because you'll see that we actually have our circle. I'm going to add the center to this as well just to make sure that that's correct. So I'm going to add the point 2 comma negative 3. For negative, I'm just using the subtraction to do it. and that does indeed look like the center. You could always double check if you weren't sure. Let's say you graphed to positive 3 by mistake. That's definitely not the center. So you'd go back and say, okay, it's got to be negative 3. So there you have it. You could also just count out, it looks like we do indeed have a radius of 4. So if you were to sketch this graph, you might just real quick do something like this. There's my center, count 1, 2, 3, 4. Now, whenever I graph circles by hand, it usually doesn't end up very good. So we'll see how this goes on the iPad. Not too bad. That would be my circle. Okay, now the next example I want to do kind of goes the opposite way. If you're given some information about the graph, can you find the equation of the circle? So let's say we want to find the equation of a circle with points (2, 5) and negative 3, 1 on opposite ends of a diameter. So at first glance, this problem kind of feels impossible because you're not given the radius and you're not given the center. So whenever you come across an impossible equation, the first thing to do is to make sense of it. Sorry, an impossible problem is to make sense of it. And oftentimes, when you make sense of a problem, that involves graphing. Or some sort of picture. So let's go ahead and graph these 2 points. So I have my x and I have my y. 1, 2, 1, 2, 3, 4, 5, and then negative 3, 1. Now I said this is a diameter, so that means the circle is probably going to look something like that. Okay. But we still don't have the center and we still don't have the radius. However, you do have some information that will help you. And this is why in math we say everything builds, because we're about to connect back to the previous unit. Let's first find the midpoint of these 2 points. Negative 3 plus 2, so x1 plus x2. 5 plus 1, so y1 plus y2. And if you do this correctly, you should end up with, I believe it's negative 1/2, and 6/2 is 3. And then we could also find the distance, which is not the radius, but it is equal to the diameter, which is related to the radius. So the square root, negative 3 minus 2 squared plus 5 minus 1 squared. Oh yeah, this is going to work out real good. So we have the square root of 25 plus 16, which is just the square root of 41. So that tells me that the radius is actually just the square root of 41 divided by 2. Yeah, math! Isn't it great when stuff works out like this? All right, so let's put it together in our equation now. X minus 1/2, so that's plus 1/2 squared, plus y minus 3 squared, fix that too, equals this squared. Now if this kind of bugs you, too bad. We can simplify this side just a little bit, because the square root of 41 over 2 squared equals, if you've forgotten this exponent rule, here it is again. You can actually distribute that squaring to each, the top and the bottom. So you end up with just 41 over 4. And so then my final answer would be, and yes, I do expect you to do that. Please don't leave something as the square root of 41 squared. It just doesn't look good. It is technically correct. So if you do it next year, wherever you may be, please tell them you went to Flag High, not Coconino High, because it's kind of embarrassing. And that brings us to the end of section 1.2. Remember, we found the intercepts and we found the equations of circles, and we did some stuff with each of those.